welcome back to my YouTube channel. So today's daily LeetCode question is sum of the distances in the tree. So we are given an undirected tree. Tree is nothing but a undirected tree is nothing but a graph. So we can move from 0 to 1 or either 1 to 0. So we are given n nodes, which means the value should be 0 to n minus 1 and n minus 1 edges will be given. So we have to get the sum of the tree from the each and every node. So the distance from the root node to all the nodes will be the sum of the root node. So let's look into an example to understand this problem. Okay guys, now let's look into this example. So here, so if we want to find the sum of the 0th node, so the distance from 0 to 1 is 1. 0 to 2 is also 1. See, there is only one distance. If the distance is nothing but just the count of the edges is the distance from the source node to the destination node. So 0 to 3 will be the 1, 2. So the distance will be 2. So the 4 will be 2. So 0 to 5 will be also 2. So if you sum up this, you will get 8. So we have to return an array which is of length n. So we need to store the values, the sum of each and every nodes. So the 0th node distance will be 8. So at the 0th position we will be storing the 8th. So if now let's count to the 1. So if we count to 1, so 1 to 0 will be, so here you can see that the distance of 0 to 1 is the same distance as the 1 to 0. So it is 1. Now 1 to 2, the distance is 2. So how to compute this? So here you can clearly see that if we can any dynamic programming approach here, so yes, if we calculate the things like if 1 to 2 is nothing but 1 to 0, 0 to 2, 1 to 0 the distance is 1, 0 to 2 the distance is 1. So if you sum up this, the result will be 2. Okay guys, now just like the same, if 1 to 3, 1 to 3 is nothing but we have the distance from 1 to 0 and 0 to 3. 1 to 0 is nothing but 1 and 0 to 3 is nothing but 2. So here you can see 1 plus 2 is 3. So the both applies to the same. 1 to 4 will be also 3 and 1 to 5 will be also 3. So if you sum up these, you will get 1 plus 2, 3, 9, 6, 9 and 12. So the array, the 1th position of the array will be 12. So likewise we have to count all the indices. So this is the example part. Now let's look into the approach part. Okay guys, this picture is from someone else's approach. So I have followed this approach and I like the way he presented it in an image. So I took help of that image to give my solution. So here, as I earlier said that, so we have the pre-computed values, so we can make use of them so to determine the next solution, right? So here answer of x is subtree of sum of x plus subtree of sum of y plus count of y. So this will be the answer of the each array index. Okay guys, the steps of this approach are convert the edges into graph. So how we will convert the edges into graph? So we have simply, we can say that we can use a hash map. So if we use a hash map, then we can convert the edges into the graph. Now we have to traverse and count the counts. So first we will count the edges count, like if 1 to 0 is 1, 0 to 2 is 1, 2 to here 2 to 5 is 1, 1, 1. So let this be 1 because the distance from the one node to next node is 1. So next we will count the source and destination parts. Now what is source and destination part? If you want the result from 1 to 0 to 1, then the resultant will be 1. If you want the distance from 0 to 5, the resultant will be 1 and 2. So we have to, so this is the traversal we have to do, and count the number of edges that will appear in between the source node and the destination node. So we have to apply this approach for the each and every child of the every node. So the 0th childs are 1 and 2, the 2th childs are 3, 4, 5. Okay guys, so we can make use of a pre-order traversal and a post-order traversal. I hope you understand the intuition and the solution video. So now let's look into the one dry run approach and a code explanation to understand this problem clearly. Okay guys, now let's look into the approach and a solution video. So code explanation is, so here you can see that first I have initialized a hash map and a count array n, and I will just fill the count array with 1 because I earlier said that so each and every node distance will be 1, so we have to compute it with 1. So initially all the edges will have count 1. So I will initialize the answer arrays to store the sum of the all nodes from the current node. So here we can convert the tree into a graph by using the compute function. If option, so it will be just like a 0 node. All the connections from the 0th node will be 1, 2, 3, 4, like something. So this will be a list and this will be our node. So in the previous graph given, our problem is, so 0 have childs for 1 and 2, 2 have childs from 3, 4, 5, 1 have child of 0, 3, 4, 5 are leaf nodes, so they don't have any childs, but they have a parent of 2 node. Second node is the parent of all those nodes. Okay guys, now let's look. So this is a first we have to do the post order traversal, then we will store the pre-order traversal. So if we doing both, so what we will do, so we will just explore the childs and compute their sum. So if we compute their sum, these two parts of the code are very important. So first we will iterate to the loop and we will perform a pre-order traversal, and we will calculate the answer child and the count child. Then we will just use a pre-order traversal to separate the count of the all nodes. So initially we have added 1 to the nodes, we will separate the count node child to the child count. So this will be happen in the pre-order traversal. I hope you understand the solution and intuition video. So the code is in the GitHub. Thank you.